of phosphorus. And then also as you move downstream, this kind of cut off here, but this is the total nitrogen stored and the total phosphorus stored of each bed. So you can see that this is aerial, so this is dependent on the actual biomass, while this is total. So this is more dependent on the actual size, the area of the mussel bed. And then when we look at nutrient recycling, as we move downstream from 0 to 160 kilometers downstream, we can see that there's a lot more nutrient recycling going on in the downstream reach. And as you look at the cumulative nitrogen and the cumulative phosphorus, they're excreting a lot more nitrogen in the densest beds. So overall, more than 600 moles of nitrogen excreted per day, 8.5 kilograms of, which equals 8.5 kilograms of nitrogen per day, which is more than 3 metric tons of nitrogen per year that they're just cycling through the system. So before, a lot of people thought only microbes were really important for this, but I think more and more people are showing that animals, big organisms, are important. And also, the other thing we saw is that the excretion into P was different across these beds. So we have higher into P in a few of these beds right here, as you'll see. And that was determined by the species that were at the site. So different species have different traits. And so this particular species, Actiniasis ligamentina, which is classified as a thermally sensitive species that has been in decline over the last 10 years, has a higher P excretion rate. So it's having a differential effect on the ecosystem than some of these other organisms. So as you can see, they have a higher aerial storage P, or as you have more of them, they have a lower P, and then as you have for storage, and then as you have more of them, you have a higher aerial excretion into P. So as you lose these organisms, there's going to be a change in the availability of nitrogen and phosphorus. And then going back to that volumetric excretion I was telling you about, so the impact of mussel nutrient remineralization is going to be temporally variable. So let me get you oriented to this figure. This dotted line is stream discharge. So the cubic meters per second of water going through the stream. So stream flow. And usually in this system in winter, in December, we have higher flows in the winter